Today we are covering the safe methods for heating refrigerant recovery cylinders, a critical competency you must demonstrate for the EPA 608 exam, appearing in both the Core and Type 2 sections. The fundamental principle here is creating a pressure differential. Imagine the system you're recovering from is at 70 psig on a cool day. Your recovery cylinder is at the same ambient temperature and thus has a similar pressure. Recovery will be slow. By safely warming the recovery cylinder, you might increase its internal pressure to 95 psig. This 25-pound pressure difference acts like a magnet, actively pulling the remaining refrigerant vapor from the system into your tank, ensuring a faster and more complete recovery. The EPA exam will directly question you on approved heating methods. A question might read, a technician needs to speed up recovery from a rooftop unit on a cold morning. Which of the following methods is acceptable? You are looking for answers that imply controlled, gentle heat application. The best answers are always an electric heating blanket specifically manufactured for refrigerant cylinders, or placing the tank in a warm water bath. These methods ensure heat is applied evenly across the cylinder's surface, preventing dangerous hotspots. A heat gun on a low setting is sometimes mentioned as technically permissible, but the exam would qualify this by stating it must be used with continuous motion and careful temperature monitoring to prevent localized overheating. Now, let's focus on the exam traps, which are all about unsafe practices. The most common trick question involves open flames. You might see a scenario like, all of the following are prohibited methods for heating a recovery cylinder except, and you'll need to pick the one safe method from a list of dangerous ones like using a propane torch or an oxyacetylene torch. Any direct flame is an immediate fail. The reason is twofold. First, the risk of catastrophic failure. Applying intense heat to one spot causes the liquid refrigerant inside to flash boil, creating an instantaneous and massive pressure spike that can exceed the cylinder's design limits, causing it to rupture violently. This brings us to the cylinder's safety features. Every recovery cylinder is rated by the Department of Transportation and has a pressure relief valve. An exam question might try to trick you by suggesting it's okay to heat the cylinder until the relief valve vents. This is completely false. The relief valve is a non-reclosing, last resort safety device designed to prevent an explosion. If it activates, you have already over-pressurized the cylinder, created an unsafe condition, and will likely have to replace the valve. The magic number to remember for your exam is 125 degrees Fahrenheit. Some sources may say 122 or 130, but 125 is a common and safe testing value. Never allow a cylinder to exceed this temperature. The second, and equally critical danger the EPA tests on is the creation of toxic gas. When halogenated refrigerants, particularly older CFCs and HCFCs like R12 and R22, are exposed to high temperatures from a flame, they undergo thermal decomposition. This process can create hydrochloric and hydrofluoric acids and most notoriously phosgene gas, a potent lung irritant used as a chemical weapon. An exam question will explicitly link heating a cylinder with a torch to the formation of phosgene. To keep the safe method straight, use this mnemonic on exam day. No glow. This reminds you to use gentle and slow heating methods and that there should be no red glow from a torch or open flame. It reinforces the core principle of control over speed. Your primary job is safety, not just speed. The exam will always prioritize the safest answer over the fastest one. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.